just get handed it. It can't all be that bad. I failed. I need to read up my U substitution. Alright. Yep. Alright. Yep. I know some of these words. Alright, now that I know how to do U substitution, there's one logical thing to do. Go back in time and prevent myself from taking that test and failing it. Stop! Who are you?
I'm you, but from the future, and
Do I really look like that?
wait, no! I'm here to help you with your test.
Oh, like do it for me?
No, I'm going to teach you.
Well, how do you do it? Well, what is U substitution? U substitution is the process of making antiderivatives or integrals easier. The first step in U substitution is to pick U. U is normally the most complicated inside function. Our goal is to put the integral in terms of U. Because we're trying to put everything in terms of U and there's a dx, we take the first derivative with respect to dx so that we can substitute du in for dx. After you simplify, you find that dx will be equal to something du. After you figure out what du is, you can substitute du and un back into the integral to get everything in terms of u. Then obviously you take the integral because it is now simpler. And then once you actually take the integral, you put in dx back in, and then you just did an integral. Good job, you. Can I see a test? Sure. Okay, so we're going to be doing the integral of 2x plus 1 squared dx. So first, we need to let u be the most complicated inside. In that case, u is going to be equal to 2x plus 1, because that is the most complicated inside. And so then, we take the derivative of u, which will be du dx. We take the derivative of u with respect to x, which will then equal 2. Okay? So now we have to put dx into terms of u. So we will multiply by dx, and we get du is equal to 2 dx. So then we divide by 2, and so we get 1/2 du is equal to dx. So now we have dx in terms of du. And so once we get that, we can now put it back into the original equation, and then we will get the integral of u squared 1/2 du. Very simple stuff. And then we can bring the 1/2 out because it's a constant multiplier. We can do that with integrals. So then we get the integral, the 1/2 times the integral of u squared du. And so then now we're going to take the integral. The integral of u squared is going to be 1/3 u to the third times 1/2 plus c. And so now we can actually simplify this whole thing down and put in the x that we had before. And so then we get 1/6. The integral of 2x plus 1 cubed plus c. That is the answer for this problem. I did the test while you were talking, and I think I got it all correct. Time to hand it in. I failed. I need more help. Let's try this again, shall we? What is the second problem? Alrighty. So first we do
Oh my god.
Cut! How do you keep forgetting your line? Did you even look at them?
No.
I want to go through this once, okay?
Okay.
Alright, so our next problem is the integral from 0 to pi halves of sine cubed of x times cosine of x dx. So first, we're going to rewrite it. We're going to rewrite it to 0 to pi halves of sine of x cubed times cosine dx. So now we need to get u. In this case, u is going to be the most complicated inside function, which is sine of x. And so we're going to do u is equal to sine of x. So, we got sine of x. And then we take the derivative like we did last time, which is then going to be du dx. So we take derivative with respect, because we take the derivative with respect to x, is equal to cosine of x. So then we times by dx, and we get du is equal to cosine of x dx. So now if you look, right to raise power, we got cosine of x dx, and since we got du is equal to cosine of x dx, we can actually substitute this whole thing in for du. And so then we will substitute everything in, and we get the integral from 0 to pi halves of u cubed times du. Not really times du, but like, well, it is. So then we take the integral, which is going to be 1/4 u to the 4th times 1/4 u 0 to pi halves. That's really bad. And then we put in back in u, so I get 1/4 sine of x to the 4th, and then 0 to pi halves. See? And so then, because we have bounds on this, we take the biggest bound, subtract it by the smallest. Now, sine of 0 is 0, 4th 0 times 1/2 is 0, so we only need to worry about sine of pi halves. And so we get sine of pi halves, which is equal to 1. And so then we get 1 to the 4th, which is just 1 times 1/4, so it's 1/4. So the integral from 0 to pi halves of sine of x cubed times cosine of x dx is equal to, well, can't write there, but 1/4. Did you get that? Oh, sorry, I got bored. Math is boring. Fine. We'll got this thing, but that means you're doing the next one. You got that? Okay, and don't screw it up. Okay, can I see the last problem? Okay, so the final problem we are going to do is 1. The integral from 1 to 2 of x plus 2 over the cubic root of 3x squared plus 12x dx, obviously dx. So u has to be the most complicated inside function. In that case, we will let u equal to 3x squared plus 12x. And then we take the derivative, which is du dx, because we take it with respect to x, is equal to 6x plus 12. Now, we need to get an x plus 2 in here, and we can, if we take out the 6, we will get du dx is equal up to 6x plus 2, and then we bring the dx over here, which we get du is equal to 6x plus 2 dx, we divide by 6, and then we get 6 du is equal up to x plus 2 dx. So then we put all of that back in, and we get that. We get the integral, and then we get 1 over the cubic root of u. Sorry, the marker is a bit bad today. 1/6 du. So now we can actually simplify this part, because the cubic root can also be written as 1/3 to the u, but because it's in the negative, if we want to like get rid of that 1 on top, we'll make it negative, and then we won't have that thing on top. So then get the integral of u to negative 1/3, 1/6 in front, du. And I left the bounds off because we have to put the bounds in terms of u, because we're not going to put it back into x. And so we would have to put x's into here, and we get u. In this case, when we put the 1 in, we get 15. And then when we put the 2 in, we get 36. And so then we would take the integral, which is in this case, the integral is 1/6 times 3/2 u to the 2/3 power? Yeah, 2/3 power from integral from 15 to 36. Now we can simplify those two numbers, and 1/6 of 3/2. So we do 1/6 times 3/2, which is get 1/4. So we get 1/4 u to that 15 to 36. And then when we put the numbers in, we would put 36 in, get a number, minus that by the number when we put that in, and we will get 1.204 as our answer. Thanks, guys. I finally passed.
Hold on.
Yes?
If I call, will you go pick up some?
Alrighty, so well, where's the paper I had? Is it in this stack by accident? It is, okay. Okay. Yeah. Yep. Stop. In the name. Sorry.